All right. Hey, Bryce. We are going to start with slide 18 and go from there, and I'll answer whatever questions you guys have. I know there's a lot of questions about what does, like, I know a lot of questions about elimination and also asking about, like, the substitution thing and when does equal values come in. Just so you guys know, equal values is actually the same thing as substitution. You're just making your y variable your equal value. Does that make sense?
Yeah.
Okay.
Yeah.
So the first one that I think there was questions on was, oops. Sorry, navigating on my part. 6x plus 8y equals -12. And the other system was 9x plus 8y equals 18. Right?
Yeah.
This is slide 18 one more time. So in order to use elimination, I have to get rid of one of those. I have to get rid of one of the variables. Now, when we use elimination, we're trying to either add or subtract the two systems together so we can essentially eliminate one of them. So when I look at this and I have 8y and 8y, I can subtract one of these two systems. And if I subtract the bottom system, I'm subtracting each piece. So now I have 6x minus 9x is -3x. And then if I have positive 8y minus, because I'm subtracting, minus positive 8y, that's eliminated. There's your elimination piece. And then this part, -12 minus 18, just so you guys kind of realize that when I do -12 and I subtract 18, that's what it's going to look like. So keep flip change. So you actually have -30. And then to figure out the value of 1x, we're going to divide both sides by -3. So x is equivalent to 10. What questions do you have? Any? Do you guys have questions?
Nope.
Does that make sense?
Yeah.
Yeah.
Okay. What else were you guys struggling with?
Slide number 20.
Slide 20?
Yep, slide 20.
This one?
Yep.
Okay. So solve the systems using elimination. So we have 3 plus 2x minus y equals 0. And then -3 minus 7y equals 10x. Well, the first problem that I have that I notice is the fact that you guys need to set this up so you have your variable has to be on the same side. So that would mean I would need to move this 2x to this side and then multiply everything by 5. Does that make sense? So if I start just by thinking about multiplying by 5, that's going to make this 15 plus 10x minus 5y equals 0. And then I can subtract 10x from each side. Oops. Which is going to give me 15 minus 5y equals -10x. So now I can take this equation, the second system, and I can just actually add these systems together. So if I have -3 minus 7y equals 10x, why can I just add them together this time?
Because you have -10x and 10x.
Yeah, so I can just combine them. So that's going to essentially give me a 0 here, right? And then I have 15 and -3, which is going to be 12. And then this is going to be 5 negatives and 7 negatives, which is 12 negatives. Right? And then we need to isolate a variable. So I have 12 minus 12y. Sorry, I ran out of space on my board. Give me a second. There we go. Magic. So I can add 12y to each side. 12 equals 12y. Isolate y, so divide by 12. 1 equals y. So this system, we were able to solve for y, then we can substitute for the x. And this is slide 20. Okay. This was slide number 20. All right. What other questions do you have?
What about 17?
17? Is that this one?
Yeah.
Okay. On 17, use a systems of equation and use substitution. One of the things for substitution again is equal values is substitution. So you could set it for equal values and you're actually using substitution. So in this case, what are you, Bryce, what were you gonna solve for?
I was, for the first one, I did 6y. I mean, for the second one, sorry, I was trying to solve for y for the bottom one.
So you were trying
Negative
to
one.
kind of do like equal values, or you were trying to
Yeah.
get substitute? Okay, so the
Yeah.
bottom one, if we want to solve for y, I can add 21x. So I'm not really using that one. And then plus 21x. So that's going to give me negative 6y equals 24 plus 21x. And then we're actually going to end up with a fraction, right?
Yeah.
So even if I start by dividing everything by 3 to kind of make my numbers a little bit smaller, I get negative 2y equals 24 divided by 3, 8, plus 7x. So if I divide by negative 2, y equals negative 4 plus 3.5, negative 3.5x. Is that right?
Yep.
Right? So then you're going
Yeah.
to take this and substitute. Were you having problems in that part?
Yeah.
Okay, so if I have 7x plus 2y equals 16. So that's where I'm at. So now I'm going to use my substitution. So 7x plus 2 times negative 4 plus, I'm going to go back to negative 7 halves over x. I'll show you why in a second. And that equals 16. We good there so far?
Yeah.
Distributive property here. So 2 times negative 4 is going to be negative 8 plus distributive property here. If I multiply by 2 and divide by 2, can't I just get rid of them? So I have negative 7x equals 16. So now if I have positive and negative 7, what happens?
Cancels out.
Cancels out. And now if I have negative 8 equals 16, what does that tell me?
No solutions.
There's no solutions to this one.
Okay.
So if you were to solve, I'm guessing if you were to solve the other one, you probably would have the same slope or the same growth. So that means your lines are going to run parallel to each other. They're never going to intersect. Does that make sense?
Yeah.
Yeah.
Okay. What other questions do you have? And this was slide 17?
Yeah.
That was just slide 17. What other questions do you have?
22. 22.
So you're supposed to solve this. Oh, come on. Okay. 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher constitutes 2 cups of water or holds, right?
Mhm.
How many cups of water can each pitcher hold? So let's figure this out. So 2 small pitchers and 1 large pitcher. So if I say 2x plus 1y equals 8, and we're saying x equals small, right? Y equals large. 1 large pitcher minus 1 small pitcher holds 2 cups of water. So 1y minus 1x equals 2. So let me show you what I wrote. Here's what I wrote. Does that make sense?
Mhm.
Now what? What should we do?
Mhm.
Well, we have
We subtract.
So we could use use elimination, you're thinking?
Yeah.
So if I wanted to use elimination, I'm going to rewrite this because it would be negative. I could rewrite this as negative 1x plus 1y equals 2, right? This
Mhm.
means the same thing as that, doesn't it?
Mhm.
Okay, so let's rewrite that. So negative 1x plus 1y equals 2. Now, in order to eliminate one of the variables, should I add or subtract this? The second one. Should I add it to the first one or subtract? We're going to subtract.
Yeah.
Now, this is where you just have to kind of think about your rules for integers. So if I have 2 minus negative 1, that's going to look 2 minus negative 1. Keep, flip, change. What do I get?
3.
So I have 3x. Now, 1 minus 1, that's gone. And 8 minus 2 equals
6.
6. So x equals 2. So what does that mean?
The small pitchers can hold 2 cups of water.
The small pitcher can hold 2 cups of water, and then you just need to use substitution to figure out how much the large pitcher holds, right?
Mhm.
Does that make sense?
Yeah.
Isn't it easier when you get to talk through some of it?
Yeah.
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 Much.
You guys are doing great.
It is.
What other questions do you have?
Hmm.
Do you have any other questions?
No.
I'm good.
Yeah.
All right.
Yeah.
Hi, Gabby.
Hi.
Mm.
All right. If you guys don't have any other questions, I'm just going to stop recording so then I can let that video upload, but I'll hang out online. So if you guys are working and you guys want me to go over anything else, let me know. Okay?
Okay.
Mhm.